Hello, my name is Muhammad Alif IDHAM bin MARIDZUAN. My matrix number is 211012593. For my part, I want to explain to you about the equation of our mini project. For the input, we are using 5 input, which is A, B, E, C, and D. For the output is Y. And this is our equation after we simplify. A bar B plus E plus CD bar. For the schematic design, this is our circuit. This is a pull-up network, and it is pull-down network. For the inverter, the inverter are connected to A, only for A. For the output is Y. For the this is like for test bench. And the test bench, the input A, B, C, D, and E are connected to voltage, and this is for the output is Y. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is AZMIN HIRZAN with my matrix number 211012582. So in my part, I'm gonna present about the comparison waveform and truth table based on circuit design. So the first example I will take is where the A is 0, B is 0, C is 0, D is 1, and E is 0. So if we take a look in truth table, the output is 1. So based on the theoretical, in PMOS section, when the input is 1, it will become an open circuit, which means the VDD cannot go through the input. So in here, in this case, the D is 1. So how the VDD can go through the output? It will go through from the C input and it will go through the output. So that's how the PMOS section. And for the NMOS, the D will become short circuit, so which means the ground can go through the D input, but however the other input is an open circuit, which means the ground cannot go through the output. So yeah, that's the first example. So let's take a look to the second example. So where the A is 0, B is 1, C is 0, D is 0, and E is 0. So if you take a look here in the truth table, the output is 1. So in PMOS section, when the input is 1, the input is a short circuit and open circuit. So in this case, the B is 1, so VDD cannot go through the B. So how it will go through? How the VDD go through the output? It will go from to the A bar, then go to the E, and it can go either D or C, and it will go to the output. So same goes to the NMOS. The B become a short circuit and the other input become a open circuit. So JND cannot go through any kind of input because the other input is open circuit. So my last example, I will take the A is 1, B is 0, C is 0, D is 1, and E is 0. So let's take a look in truth table here. The output is 1. So the input here that has 1 is A bar and D bar, and D. So if you take a look in PMOS section, the A and D bar is open circuit where the VDD cannot go through the A bar and D. So how the VDD can go through the output? It will flow through the B input and flow to the E input, then goes to the C input, then it will go to the output. So that's how PMOS works. And for the NMOS, A bar and D is a short circuit. So how the GND go through, it cannot go because the other input is an open circuit, which the ground cannot go through the input that has an open circuit. So that's all for my part. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Hello, my name is Ahmad Abshyar bin Sarkhan, and I am here to present the layout design for my mini project IC design. Okay, for the first one is the DRC. DRC is where it's check the length. It check the length of our drawing. So for the first error I got here is at polysilicon. The first error, fact is the polysilicon is need to be exactly 2 lambda. So here I got below the 2, so the error is detected. For the next error here, metal 1 need to be get 3 lambda. So at my layout here, it's only get 2 lambda, so the error is detected. And after that I fix my error, and the DRC is there are no error now. For the LVS is when we compare the layout design to our circuit diagram. For this I got an error at netlist, nets and instance. So after I fix it, I get them right. This is the right one. For my Euler path, I goes through 1 A bar to B, B goes to point 2, which across E, not C. I draw arrow here. 2 to C, and C to D. This is for my pull up network. For my pull down network, it goes to A bar, B, E, C and D. So it's got a straight polysilicon. And this is my stick diagram, and it match with the my layout. So for the conclusion, we are able to design CMOS using our own equation. Second, we are able to find the problem and correct the problem in DRC and LVS. For number 3, conclusion, we are able to tell the waveform is true or not based on the truth table. That's all. Thank you.